चलिए दोस्तों शुरू करते हैं विदाउट वेस्टिंग ए टाइम इन टुडे वीडियो वी गोइंग टू टॉक अबाउट द हाउ ACI process a ICMP packet ping packet. So what we'll do, we will see how the packet forwarding will happen in the ACI fabric when we do the ping from the Win server 1 to Win server 2. In this topology you can see that on the Win server 1 we have an IP address is 193.168.1.100 and MAC is A, and this is the part of EPGA on the leaf 1. And similar way, for this Win server 2, we have an 193.168.2.100. So it's a different subnet IP. And MAC is BBB and it's a part of EPGP on leaf 2. And there is no host connected behind the leaf 3. And both of these hosts, Windows Server 1 and Windows Server 2, is a part of BDI 500. On this BDI 500, we have configured the primary IP address is 193.168.1.1. This is the default gateway for this 1.100, and similar way this 193.162.1 is the default gateway for this subnet 2.100 IP which Win server 2 belongs. As you can see that this is our physical topology. Leaf is connected to spines and two spine and two leaf, and between the leaf 1 and leaf 2 behind we have another host a Windows server connected. If we talk about the logical topology, we have an one VRF. VRF is blue. Under that VRF, this both of the BD belong to BD 500. On this BD, only single BD we have, and on this BD we have two IP are configured. This is the primary IP and this is the secondary IP configured. And primary IP, which is the BD 500, is belong to EPGA, and this secondary IP belong to the endpoint group B. Okay. As we know, these are the forwarding component of the ACI. ACI will when leave to the forwarding, it first check the endpoint table, show endpoint VRF tenant name, called VRF name. After that, we can get the endpoint detail. And if there is no entry in the endpoint table, so it will check the routing table, read information weight LPM table, where the slash all known slash 32 entry will be there. So lookup order is first check endpoint table, then rib lookup. And EPG again is a group of endpoints. Okay. So once this Windows Server 1 we try to ping to this Windows Server 2, so it will come to know this destination IP 193.168.2.100 belong to a different subnet. So this will try to send a packet to the default gateway. To complete the packet, as we know on the payload, we need to attach a two header, L3 header and L3 header. We have an L3 header. This is the source IP and this destination IP. But in the case of L2 header, source MAC with the MAC AA and destination MAC with the gateway MAC. To get the gateway MAC, it will send the R packet. Once the R packet will reach to this default gateway, which is configured on the leaf 1, 193.168.1.1. So leaf 1 will learn the source MAC and source IP from the R packet. Okay. And after that, leaf 1 will do notify this. Leaf 1 will report this entry to the spine, and spine will update the kube database with this Windows server. This IP, this MAC is connected behind the leaf 1, and after leaf 1 will reply to the Windows server with the gateway MAC. So with the help of R packet from Windows server 1 to leaf 1, Windows server will learn the gateway MAC address. Okay, now the packet is ready. ICMP packet, ICMP is the payload, and source IP is the destination IP in this. Source MAC is the this, and destination MAC is gateway MAC. This packet will reach to the leaf. Okay, leaf will check the endpoint table. So there is no entry in the endpoint table for the 193.168.2.100. So it will check the rib in the routing information bit. It will find the entry for the subnet. Okay, so it will proxy the packet to the spine, and spine will check the entry for the kube database. If there is no entry in the kube database, spine will drop the packet. In the case of L2, traffic will be simply dropped, but in the case of L3, traffic will be the Arp clean. Okay, so spine will first drop the packet as there is no entry in the database, and after that it will generate the Arp glean packet. Okay, this Arp glean packet, spine will send all over the leaf 1, leaf 2, leaf 3. So as we know, on the leaf 1 and leaf 2, we have another BD entry. This BD 500 is configured on this port, and on the leaf 2 also on it 1/3, this BD is 500 is deployed. So this R glean packet will be sent out to these ports, which are the port are part of BD 500. As we can see on the leaf 300, there is no BD 500, there is no connected, so leaf 3 will simply ignore this packet. And once this packet R glean packet, leaf will process this packet to the Windows Server 2. Windows Server will reply, and with the help of this leaf 2 will learn the Windows Server 2 entry, Once leaf 2 has learned the entry about this 193.162.100 and this MAC BBP, it will report the similar way like leaf 1 did. This will report this entry to the spine. Spine again will update the database in the COOP table. Okay. In the second ICMP packet, this was the flow we have seen for the first ICMP packet. In the second ICMP packet, again when this packet reaches to the leaf, so leaf will again process back to the spine. Now spine have an earlier spine there was no entry in the COOP database. Now spine have an entry in the COOP database, so it will simply forward the packet to the leaf 2. Okay, and leaf 2 will further send it to the packet to the Windows Server 2. In the case, once this Windows Server reply, now leaf 2 have an all now when Windows with this leaf 2 have got this packet to the Windows Server 2, it then simply reply from the Windows Server 2 to leaf 2. Okay, leaf 2 now have an entry for this endpoint. When spine have sent this packet to do, on that time leaf 2 have learned this remote entry. Windows Server is connected behind the leaf 1. Okay, and now this once this reply packet is the leaf 2 already and already entry in the endpoint table, so this will simply send a packet to the leaf 1. Okay, now leaf 1 will learn the remote entry about the Windows Server 2 which is connected behind the leaf 2. So this is how end-to-end forwarding for the ICMP packet happen in the ACA fabric, and how we have seen how leaf 1 and leaf 2 learn the local and remote learning about the hosts. So here I put in the definition for the Arp Gleaning. So we can say Arp Gleaning is used for the detection of silent host, and we can say it is a process in which spines will generate the Arp request for the destination IP when the entry does not exist in the COOP database, which we have seen while we have done the end-to-end packet work for the ICMP.